Ah, the Stream Deck. A glorified keyboard with a glorified price. I can't afford that, so I made my own Micro Deck. A single button that can be programmed to do just about anything. It can play some sounds. What the hell? What the can even shut down my computer if I want it. There's only one small tiny problem. It lacks character. So we're gonna go and add more buttons, add some LEDs, add a display, and size doesn't really matter, but let's make this deck bigger. A Stream Deck is basically a keyboard extension where you can bind buttons to do specific tasks on your computer. Since the buttons are the main component here, let's get started with that. I tried finding buttons with displays, but I'm not even sure they exist. So we're kind of left with a few choices. I could use the same button from here, or I could use a different type of button that is easier to use, easy to solder, a touch capacitive sensor button. So how it works is you need an electric conductor to touch it, which is why it works with my skin, but not with this plastic thing. Since we don't really have a small display to show what the button does, we're gonna have to use the next best thing, LED lights. A color display would be sufficient, I guess. It's better than nothing. Now that we've got the core hardware down, let's solder things and get some software started. So the idea here is that each time I press any of these buttons, the D1 Mini will send some type of API request to the Flask application in my computer. The software would then translate these requests into tasks or actions. For some reason, I shaped it like this to be more ergonomic, but kind of looks ugly, and I'm not sure if I'm gonna keep that design. Now it's time to integration test it with a software. I wrote a really simple Flask app just to test the comms between the two components, and look at that, it doesn't fucking work. Oh my. I thought my D1 Mini was broken, and it turns out that I cannot use that specific pin. I think it needs to pull low or high, I don't know. So we're gonna have to use the D1 Mini's bigger brother, the ESP32 Node MCU. Okay, now that's done, we can now write some actual software. Since this is supposed to be a simple project, I needed to make sure not to over-engineer it. And after a few weeks of coding, well, here it is. I'm not gonna go over the code because that's boring. But I did want to quickly go over the concept of design patterns. Basically, it's exactly what the name suggests, a pattern for designing code. Apart from solving complex design problems, it also makes the code way easier to extend and maintain, even after the original author is left. Okay, enough talking, more testing. Let's fire it up. So if I press this button, it should toggle mute. Okay, that's good enough testing for now. I didn't really like the design of the previous one, so I made this face guide so I can correctly solder these buttons in their right place. We'll put our touch capacitive buttons over here, a display over here, a rotary encoder over here. These tiny little squares are holes for the LED lights. I then soldered the display and the rotary encoder. For some reason, I couldn't buy a display or an encoder that wasn't already pre-soldered. I just bought one of these male to female wires, and it made things much easier. Then I saved the worst for last, the button LEDs. I absolutely hate soldering tiny pieces, and the plan was to solder 5 different small LEDs under each button, but this entire process just sucked. I ended up soldering for a couple of hours, even using a glue gun to keep things in place. And in the end, it did not work. Something must have gone wrong from my frustration of this entire process. I also ended up getting really bad stomach pain, probably from breathing in all the fumes. I certainly did not want to go through that again, so I ended up compromising and using this LED stick that is already soldered together. I just need to tweak the design a little bit, and by a little bit I mean a lot. Look at these, I have multiple versions of this. But what's cool is that I get 2 or 3 extra LEDs that I can use for something in the future. So there's just one last problem that we have to solve, which is KRO, or key rollover. It's a term that describes how many keys a keyboard can register when pressed at the same time. Different keyboards have different KRO values, and while my Stream Deck isn't affected by KRO in the same way as a typical keyboard. I'm still running into a similar issue with simultaneous inputs. I cannot just press all the buttons and have all the functions run because my program waits until the last task is completed. We can solve it the right way and use threads, or I can make a two-liner addition that solves all of my issues. There's multiple solutions to the same problem. I just chose the easier route. Although it would be good to use threads from the start, I don't think there's any other use for it besides what we've already encountered. So I don't want to spend all that time building something that I don't need in the foreseeable future. And that was the last of our problems. I mean, there's other problems, like where's the rest of it? But MVP-wise, it works. It's good enough. So let me show you what it can really do. I don't like having icons on my desktop, so this really fixes that issue for me. I also started learning to play the drums because each year I like to do something new. I put up some progress updates a few times a week on this channel if you're interested, but whenever I need to record some audio, I have to get up, go to my computer, and press start recording, go back, and sit down and play. You know, it's a lot of work versus now. I can just click this button and it starts recording, and it just makes my workflow more streamlined. I have this feature called modes, so although I only have 5 buttons, I can technically have more than that, like 10 or 20 different functions. I just have to iterate through all the different modes. This deck still isn't as good as the real one, but with more software updates such as app awareness, I think we could get really close. In the next iteration, I'm going to be integrating some AI. I think using an LLM would essentially remove the need for memorizing voice commands. Instead of having to say the exact commands like shut down, volume up, I could just say, yo, can you turn it down? Can you print my last STL file, please? Jarvis, it's goon time. Let's get to the price. I spent around $18.98 for all the parts. The time spent on software probably costs more than that. I could have gotten a used one close to that price, but that's okay because the real value is in the things that we've learned. Yeah, let's go with that. If you like this video, check out this other one where I tried to make a guitar pedal from scratch, or this one where I used AI to try fixing my posture.